All right, so we're looking over stuff, how to solve by elimination. All right, now the things I was writing down the other day is kind of what I typed out a little bit. We're going to write down some of it again just to make sure we're all on the same page, okay? All right, so now I did change the order from the original homework. If somebody tried it that first day, I don't think any of y'all did. That was mainly the 8A kids, but we'll go from there. All right, here's our problem. There's our system. All right. And of course, my voice decides to try to crap out on me when I'm recording. When I'm saying in the columns, I'm talking about those columns. The X's, the Y's, the constants should all be together. All right. If you look at these, you need to ask yourself, do we have same terms, different signs? Okay. In this would be yes, the X values. Okay. Technically, the same terms, different signs. These are additive inverses. This is stuff that you use to solve those 1 and 2 step and multi-step equations to make stuff go away. Okay. Now, if we do that, all right, if we combine them, those go away. I'm left with 6y. Yep. And then this is negative 30, not 63, 36. All right. Now, from here, you would just divide. And we get y equals negative 6. Awesome. Okay. So we did what we were supposed to. We eliminated by that easiest route. Okay. Now, I do have one of each of every one. This was the one that people really understood the other day. I totally understand it's the easiest version. Okay. The other ones get a little bit more difficult. All right. So now, how do we find? How do we get X? Okay. How do we get X now? Well, we get X by plugging in Y to either the top or the bottom. That Y value of negative 6, where we see Y, and then solving for X. Okay, so what do y'all want to use, top or bottom? Okay, so we're using bottom with this one, which is 4x plus 8y equals negative 24. And we're going to plug in this negative 6 right here. Okay, excuse me. All right, so we have 4x minus 48, excuse me, equals negative 24. All right, we're going to add 48 to both sides. For x equals 24. We divide. So x equals 6. Now, our solution for this is 6, negative 6, okay? That's the xy intercept. If we were to actually graph these, personally, I would not want to graph these on a graph. Digitally would be okay. But that's where they would intersect, okay? And I know the solving by graphing is usually easier for people because it's very visual. This is when you do stuff when it's kind of hard to graph those because sometimes it doesn't show up very well. Okay. So that was the first problem from the homework. All right. Now, here's the second one. Do we have same terms, different signs? This would be a yes. This time it's the y value. Okay, this right here. Because if we combine these, if I combine 1x and 2x, I get 3x. The y's go away, and this becomes 30. So, divided by 3, and x equals 10. All right. So, usually with this elimination process, getting with ones like these, it's usually they eliminate very easy. You got one step equation, you get one of the variables. Okay. Now, what about y? What does y equal? Well, we got to use one of these equations again and plug in what we just found. Okay. Which one do y'all want to use now, top or bottom? Huh? It sounded like you said top them. Top. Okay, using top, which is x minus y equals 11. All right. So we're going to plug in where x was. Actually, you don't have to do parentheses on this one because it's not being multiplied by anything. So this becomes just 10 right here. Then minus y equals 11. All right. So we need to subtract this 10. We have negative 1 right here. And we can't have a negative y. Okay. So we would divide by negative 1. So we get y equals 1. Okay. Did I do that right? Yep. Nope. It's supposed to be negative 1. I put too many negatives in there. This should be a positive 1 right here. I was trying to do the answer beforehand. The reason why I don't like, if we're working on a problem, shouting out the answer is usually not the best thing. It's kind of like when you take a trip. Okay, yeah, you went somewhere kind of cool, but usually the best stories come from just getting there. Okay, so in this solution, we have 10, negative 1. All right. Yeah, it's very spaced out and it's only copied on the front side. So everybody can see very well. One student, for those listening at home, one of the students' eyes got about this big around when they looked at all the notes. All right. And yes, I just broke the fourth wall. It's like if Deadpool was your math teacher. All right, now, that would be hilarious. All right. Now, this is where people started to fall off the thinking train 2 days ago. Okay. People had, okay, yes, same terms, different size. Pew, we're good. Awesome. Love it. This, what the heck? Okay. So, do we have same terms, different signs? No. Can we multiply one of the equations to get rid of a variable? Well, this is yes. It doesn't matter if I multiply the top or the bottom because these are the same term, different signs. Same term, same signs. Okay, they won't cancel out. We need one of them to go away. Okay. Do you need me? Nope. Go ahead. All right. So now, me personally, just being weird, Mr. J, when I do this, I like to multiply the bottom one by negative 1. And it doesn't matter. You could use the top. The reason why I do it is because I remember way back when in the elementary school where you'd have this number minus this number. That's the only reason why. All right. So if we multiply all this by negative 1, uh, we had one. Hang on a second. It's all right. I'll just. Okay, so jumping back into this one, if I multiply all this by negative, now I have a positive 3x, a minus y, and a positive 5. Okay, now I should have the same terms, different signs. Okay, because that's the goal. The goal is to get rid of one of these things. Okay, so if we look at this, well, we combine, yes, our y's cancel. That was the goal. I now have 11x equals negative 11, because all I did was just combine in my little columns. If I divide by 11, I get x equals negative 1. Bam. Okay. So on some of these where you have to manipulate them, some people say manipulate, some people say multiply, some people say rearrange. What makes sense to you, I don't care. We're just got to do something to get rid of somebody. Okay. We're putting a hit out on one of these variables and they got to go. Okay. They are now going to be sleeping with the fishes. Okay. Sorry, I watched a lot of mob stuff while we were in Snowvid or snow vacation or something. Okay. It was really fun. All right. Now we have X. We need to find Y. Which one do you all want to use, top or bottom? Top. Okay, good. I heard top very well instead of top them. All right. The fact that I don't have super great hearing and people are wearing masks and you're behind an anti-COVID shield is not very great for me. All right. So I'm plugging in negative 1. I just took that top equation right there. You don't have to rewrite it if you don't want to. I'm doing it so it's more out there. Okay. So here's this. Now 8 times negative 1 is negative 8 plus y equals negative 16. All right. We're going to do the opposite and add 8. Y equals negative 8. All right. So this one actually, when we plugged it back in, it wasn't that, wasn't as bad. So our solution is negative 1, negative 8. And I'm sorry I didn't write out all solution. That's an old thing from our college professor. He made us used to write it like that. And if we didn't write that on our papers, we got counted off. Whatever, Cheddar. All right. So we've done 3 of them now. We've done one where we had to multiply 1 by negative 1. So do we feel a little bit better than we did on 2 days ago? Okay, good. I've got more people nodding their head. They're like, yeah, I might not have to use photo math so much on my homework. And I'm like, I really wish people would start. Some of y'all's grades look like Cheerios. Okay, now. All right. So, do we have same terms, different signs? We're looking. This is a no. Okay. Can we multiply one of the equations by something so we can get rid of a variable? Well, yeah. If we just look at what we have. Come on, there you go. All right, I don't like that anyways. All right, if we look at just our x values, we already have a negative 4 and we have a positive 1. We could easily, if we wanted to, if we decided to get rid of the x, we could multiply the bottom the equation by 4. All right, now, also, if we look at our y values, I have a negative 3 and I have a positive 9. I could still multiply that bottom equation by a 3 and make my y's go away if I wanted my y's to go away. Okay, now remember, we're just looking at the ones with the letters. Don't say, well, I don't know what I could do with the 9 and negative 6. Okay, that's not what we're doing. Yes, we can do that. So we need to think, who is going to go away? Pick a letter. Huh? Y. All right? Y is the loser. Okay? So we're going to get rid of Y. Get rid of Y. All right. So if we do that, if we just got to leave the top alone. Now, since this is a positive 9 here, I want this to be a negative 9 down here. What would I have to multiply by to make this be a negative 9? A 3. I would have to multiply all this equation by 3. And when I do that, well, 3 times x is 3x. 3 times negative 3y is negative 9y. Ching. And this ends up being negative 18. All right. So, okay, I'm planning my work and then I'm working my plan. We said we're going to get rid of y. We're about to. Okay. The forensic people will not be able to figure out who did it. They'll just be able to find that y is now gone. Okay. Now, negative 4 plus 3 is just a negative x or negative 1x. If you write the 1 there, that's fine. Okay. This ends up being negative 9. All right. So when we do this, this ends up just being positive 9. Ta-da! So we got the x. We said we're going to get rid of the y. We got rid of the y. We found what x equals. Now we actually have to go back and worry about y. Now we've got to do some body recovery. Okay. So we got to dredge. Now, top or bottom? Bottom. I think I heard bottom. Did I hear bottom from people? Okay. You would think with having to wear these masks all the time that my hearing would be better because my ears look like satellite dishes now, but you know, not so much. All right. So we're using the bottom. We're going to plug in this 9 right here. So 9 goes here because that's where x was. Okay. All right. So I'm going to, now it's there. Now I got to subtract it because that's just the way life happens. It's here. Now it's not. I get negative 15. Oh my gosh. If you do not keep that bottle under control, I'm going to shove it so far up your sinus cavity, it's not going to be able to move. Okay. No, that's a promise. And I'm recording and I'm going to put it on YouTube and I don't care because it's being annoying. Okay. Yes, it is your bad. All right. So our solution is 9.5, just like Dolly Parton. What did I just say, little girl? You know what? You know what would keep that from falling? Stick it in your bag. Well, she. This is why I don't have hair, people. Okay. You know, you fixing to catch it. Do you really want to bite me? Do you want to catch these hands? All right. So now, how many we've done? This is now, we've done 4 of them. Starting to feel a little bit better. Maybe we're not lost in the woods a little bit. Okay. I still think people are trying to think they can go from right here to the solution all at one step. I'm going to have to stop recording so I can just go delete a student. All right. Now, this is the one that we got. This is the big thinker. Okay. which, yeah. Originally, I had this in the middle of the homework, and then I looked at it. I was like, no, it needs to be at the bottom. That way, it progresses. Okay. So, of course, if it was in the middle and I was doing that, I was like, easy, easy, whoop, skip and keep going. Okay. All right. Do we have the same terms, different signs? This is a big fat no, just like all the girls used to tell me in high school. Now, can we multiply one of the equations by something? Okay. Probably. We can, and look, this is when we turn into an infomercial person. Not one, but both. Okay. Because there's no way that we can evenly multiply something into two to make it be 5 or 8 to be 20. All right. So, which letter? You're about to pick. This is like a choose your own adventure. We're about to choose our own adventure on how to get rid of one of these letters, one of these variables. Okay. Somebody pick one. There's only two. X. Okay. Did you say 4? By the way, for the people listening at home, it was the same girl that was trying to chew on a water bottle and was being very loud. When I said pick a letter, she said 4. Don't you want to be a teacher too? Now, all right. So if we're getting rid of X, let's think of things that we can do. All right. This is a 2 and this is a 5. Is there a number that both 2 and 5 will both go into? Oh, okay. The girl that said a number for a letter actually had the right answer. They will both go into 10. All right. So how are we going to make this top? What are we going to have to multiply this 2x by to make it be 10x? 5. So we got to multiply everything by 5. Okay. All right. This one right here. What am I going to have to multiply this by now to make this be a negative 10x? What am I going to have to multiply this negative 5 by? Just a 2. So I multiply everything by a 2. All right. So if I have 10 and I take 10 away, what do I have? 0. Good, because that's the letter that we said must go. If I have 40 and I take away 40, what do I have? Shut your face. The students say 100. Stupidity is more contagious than COVID. Okay, now if I have 30 of something and 30 go away, what do I now have? 0. Nothing. Okay, so these aren't pacing zeros, these are here to stay. Now, 0 plus 0 is 0. It would be IMS or infinitely many solutions. Okay, a lot of people would write IMS because you know who wants to take that time to actually write out infinitely many solutions. The good thing is all your homework and tests are online, and it's a match. Okay, you just match. Everybody still does remember that the homework and stuff is online, right? Okay. I had somebody say, "Well, they said they're doing the homework in class." I said, "No, they're not." I sent them a screenshot. They said, "Oh, isn't it on paper?" I'm like, "No, those are notes." Okay. All right. So that was the homework. Hopefully, it feels a little bit better. Now we're going to hang on to that. Okay. Just like Journey says, hold on to that VEE link, and we're going to keep going. All right. Now, to determine the best method to use is going to depend on what it's set up by. And here I thought I was being super awesome when I made this handout, but you see there is a topo right down here, and I please need you to fix that. All right. But if we're going over graphing, we're going to use graphing if they're both y equals something. Okay. Both equations are y equals. All right. And it's substitution if one equation has a variable alone. Okay. And this is what I mean by alone. That y is all by itself. This x, now that I fixed it because I was a weirdo the other day, is now all by itself. Okay. So this is when you know to use substitution. All right. Because now in 2 weeks, the juniors are going to take the ACT. That's a virtual day for y'all. We'll talk about that later. But they will have a problem like this. It says solve the following system of equations. It doesn't say solve by graphing. It doesn't say solve by elimination. It doesn't say solve by substitution. You get the pick. So you need to look at what you're given to see what you're going to do. Okay. Now, elimination. This was the thorn in our sides the other day. All right. If we have the same term, different signs. Okay. That's our favorite one. It's super easy, nice and clean, gets rid of everything, and we're good to go. All right. And this is where we lost people the other day, but I think we got you back on the thought process here. Excuse me. That can we get rid of a variable by multiplying by -1? And this, look, and this is when they're the same terms, same sign. Okay. This is when they're the same term, same sign. Okay. That's so we have an x, both positive x on the top and bottom right there. And we can look at it from there. And then the last one, and this is everybody's least favorite, okay, because there's more work to do, is multiply one equation by another. Sometimes you have to do both, as we saw in the last thing. Like I could easily change this to -5 or -10x by multiplying it by -5 if I wanted to get rid of x. And this one I can multiply the top by -2 if I wanted to get rid of y. What you multiply by is determined by what you want to get rid of. Okay, it's one of those if-then statements. If you get rid of x, you do this. If you get rid of y, you do this. Okay, give Mr. Jeffries a $20 bill, I'll be happy. No. All right. Y'all can't do that, but it would be funny. All right. So let's look at this. Why would you solve this system by graphing? Well, let's see. I wonder what we had just had on our notes. Yeah. Both are y equals. Okay. They're both y equals something. That means they're in slope intercept form. Y equals mx plus b form. Okay. All right. For this one, the b is 4. Oh, shucks. What was that? My fat finger hit something. Now it's weird. This is 4. My m is 3. Remember, this is my b. This is my m. All right. For this one, my b is -5. My m is 3. Now, we learned something on Monday. Y'all weren't here, but if you watched the video, which I still don't think some of you are doing, if you watched the video, then you would have saw that if you have the same slope, the answer or your solution is no solution. Okay. And the reason why is because they will never touch each other. They will go side by side. Am I okay? Well, I'm planning thoughts of maybe I shouldn't say that to that student, or maybe throwing that heavy object at that student's face is not such a great idea. All right. Now, this we should know it's substitution. Why should we know it's substitution? Because y is alone. Okay, it's isolated. Okay, it's like that person that you find attractive that you want to go up to and say, "How you doing?" Okay. So apparently that student also doesn't find very many people attractive. All right. So our first step is we're going to plug in for y, not the number 4. We're going to take all this right here and plug it in like this. So now we're going to have 2x plus 3, big parentheses, 6, and I get x plus 7. All right. All I do is take all that in. Now remember, for some of us that like to try to put letters back in when they're not supposed to, we're plugging that in, so now we have no y's. Now we all have x's, and we can solve this from here. All right, so our next step is we're going to distribute. Okay, because there's parentheses. All right, so 2x, we don't do anything with that. 3 times x is 3x. 3 times 7 is 21. And then 6 kind of tags along. All right. So from here, we're going to combine like terms. These steps should look familiar. These are the same steps that we did for the multi-step equations in Unit 1. So 2x plus 3x, now we have 5x plus 21 equals 6. Now we're going to put the constants together, not a person whose name is Constance, but like the numbers without the letters. All right, and we do that, we're going to subtract 21 from both sides. Okay. And we now have 5x equals all right, and then we're going to divide to get x by itself. And now we get x equals -3. Okay, awesome. But we only have half the solution. Okay, we only have an x. We need an x and a y. So I wonder what we need to do to find y. What did we do earlier when we were going over the homework, when we got one of the variables? What did we do to find the other one? Yeah, plug in. We're going to plug into this because y is already on one side by itself. So if I plug in this -3 plus 7, well, -3 plus 7 is 4. So my solution is -3, 4. Now, yes, a lot of stuff going on right there. Lots of steps. I know I probably worked it out faster than some of y'all do normally. If it seems like I'm doing this fast, there's probably a reason why. I've been doing it since before you were born. Okay. And some people will have to do the step and then sit back and look at it. They'll have to take another mad minute. That is totally fine. I would prefer you do that instead of sitting there rushing through. Okay. This is a reflex for me. I'm already programmed. Okay. I see 2x and 3. I know I'm going to combine like terms. I see parentheses. I know I'm going to distribute. I've been doing this for a long time. Okay. All right. So a little bit better with the substitution, right? Not trying to plug in another variable where it's not supposed to be. Certain student over there that I don't want to say their name. Just glare at you awkwardly. Okay. Now, elimination. All right. What variable would we get rid of first? Let's look at the problem and think about what's the easiest path for us to take. Don't say it out loud yet. Just sit there and look for it. When you got it, give me a thumbs up if you got an idea. You got 2 thumbs. Oh, got a thumb from that person. Okay, got y'all. Okay, I got a quick thumb. Okay, that's the wrong finger, and you're supposed to do a thumb, not the middle finger. I'm just joking. Nobody did that, but that would be funnier. All right, so I know what teachers ever say, if you have the answer, flip me off. Okay, that would be hilarious. All right. So what did y'all get? What did y'all think would be the easiest variable to get rid of? You gave me an equation. I need a letter. Why? Why would be the easiest? And this is why. Okay, this y'all might want to write easiest. Okay, the reason why it's the easiest is because this is a 3y and this is a negative 1y. I can easily multiply the bottom by 3 and the y's cancel. Some of y'all are like, I'm not seeing that just yet. Look, it's certain characteristics, okay? We're looking for different signs. We're looking for least common multiples, things like that, okay? You're a mathematical profiler now. You're with the MBI, the Math Bureau of Infinite Solutions, okay? I can multiply this because I want this right here. I want a negative 3y, so the y's go away because that's the path I've chosen. And then somebody let me multiply 3 times 3 and get 6. I hate everybody. All right, so this is 11x and this is 66. All right. So we have x equals 6. Awesome. Now I have x. Okay. Now, what are we going to do to find y? Which one are we going to use? Are we going to use the top or the bottom? Top, okay. Some people, you always want to use the top. That's absolutely fine. Some people always want to get rid of x. It may make your life harder, but if you understand how to do it and get it right every time, that's awesome. Okay, so the top. For those that don't know what's going on, the student that was being really loud while was still being really loud. All right. So all I did was substitute in where x was x. I put in the 6. This is the old plug and chug, like y'all probably did in 7th and 8th grade, or 7th and 3/4 of 8th grade. Okay. So this becomes 12. All right. Subtract 12, subtract 12. 3y equals 3. Look at there. Well, I declare y is just 1. So our solution is 6, 1. Yes, all dang it.